Hello YouTubers. In this video I will talk about PROFINET IO network. Please do not forget to like the video and subscribe to the channel. What is PROFINET? Simplest explanation would be, it's a standard, designed for industrial networking in automation. PROFINET was developed combining the success of the PROFIBUS with the best of the Ethernet. PROFINET works on the same principle as PROFIBUS. But unlike the PROFIBUS, PROFINET operates on higher carrier frequencies, which are from 100 to 600 MHz, while carrier frequencies of the PROFIBUS are 3 to 20 MHz. There can be used 2 to 4 twisted pair cables. It enables a bandwidth from 10 to 1000 megabaud per second, while maximum bandwidth of the PROFIBUS is 12 megabaud per second. Different cables can be used in the same application, depending on your used hardware. In general, PROFINET is the open industrial Ethernet standard of PROFIBUS for automation systems. It uses TCP IP and IT standards, so PROFINET and standard Ethernet devices can be mixed in one network. There are several versions of the PROFINET: CBA and IO. CBA stands for Component-Based Automation. It is for distributed plants, component engineering. IO stands for Input-Output. It is for controlling actuators, sensors, drives by using one or several controllers. Today's topic is PROFINET IO. PROFINET IO system is assembled from the following devices: IO controllers, IO devices, iDevices, IO supervisors. All these devices are connected to the PROFINET IO network. IO controller is a PLC, CNC, robot control, or motion controller. It controls automation tasks, as the automation program runs on it. Compared to PROFIBUS, it is like Class 1 master. IO controller provides output data to the configured devices. In return, it reads input data from IO devices. IO device is a distributed field device. It is linked to IO controller via PROFINET IO. IO device can be linked to several IO controllers. These are so-called shared devices. Compared to PROFIBUS, IO devices are slaves. IO device is opposite to the IO controller. It provides input data and consumes output data. iDevice or Intelligent IO device allows simple and fast communication between two PROFINET IO devices. It enables access to the IO address via the PROFINET IO protocol without using PN-to-PN couplers. In general terms, iDevice is a controller that is connected to the higher level controller. iDevice can be a CPU with only central modules. They have not their own IO system with distributed IO. In this case, it is configured and parameterized as an IO device in a distributed IO system. In other cases, iDevice can be the CPU, that has central modules and its own IO system with distributed IO devices. In this case, iDevice can be an IO device for higher level controller, and at the same time it can be an IO controller for IO devices on its PROFINET IO network, or a DP master for a subordinate PROFIBUS system via PROFIBUS interface. IO supervisors are typically programming devices, PCs, or HMI. They can be used for commissioning and diagnostics. Compared to PROFIBUS, it is like Class 2 master. In TIA portal, all parameters relevant to PROFINET are defined and transferred to the SIEMENS CPU and from there to the PROFINET devices. The CPU defines IP addresses and PN names according to the topology that was made in the TIA portal. If you want to add device into the topology, that device must support the PROFINET mechanism. In other words, PROFINET IO controllers and IO devices must support following PROFINET functions: IRT or isochronous real-time communication, prioritized startup, MRP or media redundancy, PROFIEnergy, shared device, iDevice, isochronous mode of process data, principle of data exchange. Data exchange between IO controller and IO device is provided in transfer areas. These areas are called IO areas. As an example, I will create a simple sketch of PROFINET IO network with two devices, IO controller and IO device. Here is my IO controller. It is a PLC that supports PROFINET functions. Automation program runs on it, so it controls automation tasks. Here is another PLC, it will take a role of IO device. As it is intelligent component, it is called iDevice. Both of the devices are connected into the PROFINET IO network. Visually both devices looks identical. Both are PLCs, but the one on the left is IO controller and the one on the right is IO device. The left PLC contains automation program. The right one is also PLC, but it is connected to the higher level PLC, that is on the left. So far we have IO controller, IO device, and both of them are connected to the PROFINET IO network. The data exchange between IO controller and IO device is realized via transfer areas. IO controller provides output data to the inputs of the IO device. So it can be called as output provider. IO device is an opposite to the IO controller, it consumes output data of the IO controller, so it can be called as output consumer. IO controller consumes input data of the IO device, so it can be called as input consumer. IO device is an opposite, it provides input data to the IO controller, so it can be called as input data provider. That is how PROFINET IO system with IO controller and iDevice works. Let's create one in TIA portal. My setup of PROFINET IO network is as follows: S7-1516F3PNDP as IO controller and S7-1214C as IO device. First let's add CPU that will be IO controller. Open network view of your project. Browse your hardware catalog to find suitable CPU. Drag and drop the controller onto the network view edit. Configure PN subnets. Configuration of the IO controller is done for now. Now let's add IO device. Browse your hardware catalog to find suitable device. Drag and drop it onto the network view edit. This S7-1214C CPU needs to be configured as I/O device. Click on its PROFINET interface. Select Ethernet addresses in the General tab of Properties. Select any created subnet of the I/O controller, so both devices will be in the same subnet. Both controllers are in the same subnet. Now you need to change behavior of the S7-1214C CPU so that it will act as I/O device. Select Operating Mode in the General tab of Properties. Tick the checkbox I/O device. Now S7-1214C CPU is configured to act as I/O device. If you take a closer look at your device, you will see a new text under the name, which says, "Not assigned." It means that your I/O device has no assigned I/O controller. Let's assign I/O controller to I/O device. To assign I/O controller, select one from drop-down list. Expand drop-down list and select PN interface of your I/O controller. What do we have now? Instead of not assigned, you can see the name of the I/O controller that is assigned to the current I/O device. So, we have I/O controller, I/O device with assigned I/O controller and PROFINET IO network. Next step is to create transfer areas. These areas will be used to exchange data between I/O controller and I/O device. To create transfer areas, click on the PN interface of your I/O device, in this case S7-1214C CPU. Go to the iDevice Communication section, which can be found under the Operating Mode in General tab of the Properties. Transfer Area table opens up. First column, Transfer Area, holds the name of the transfer area. It is generated automatically after you click on Add New. It can be changed to suit your needs. Second column, Type, holds the type of transfer area. It can be CD, FPS, or TM. CD is Data Exchange Controller Device. FPS is Data Exchange Profi Safe, it is safety related. TM is Transfer Module Mapping. Next column, Address in I/O Controller, holds the address from the perspective of the I/O controller. Next column is Direction of Transfer. Here you can set transmission direction of communication relations. Direction is changed by clicking the arrow. The I/O addresses are reassigned automatically, depending on the set direction. Next column, Address in iDevice, holds the address from perspective of the I/O device for specified transfer area. Next column, Length, holds the length of the specified transfer area. Length is counted in bytes. Let's create some transfer areas. Click on Add New to add new transfer area. The name of transfer area is generated automatically. Let's rename it. Direction is also generated automatically. It indicates that this data area will send data from I/O controller to I/O device. Addresses are also pre-assigned automatically. Let's change the output address of the I/O controller and input address of I/O device. The length of the transfer area is 1 byte, let's increase it. This setup indicates that I/O device will read 2 bytes of I/O controller output, starting at 200, into the input address, starting at 200. Let's add another transfer area as a feedback to the I/O controller. Click on Add New. Rename the transfer area. Click on the arrow to change the direction. Let's change the input address of the I/O controller and output address of I/O device. And increase the length of the transfer area. This setup means that I/O device replies 2 output bytes, starting at 200, to the 2 bytes of inputs of I/O controller, starting on input 200. Configuration of transfer areas is finished. If you click on the PROFINET IO network and go to Overview of Addresses, you can overview all configured transfer areas. All is done. Compile, save, and download projects to the PLCs. Connection between I/O controller and I/O device will be established as soon as configuration files will be downloaded to the both PLCs. Let's test the configuration. Let's try to read the outputs of the I/O controller on the I/O device side. As you can see, the values of the outputs of the I/O controller are represented into the corresponding inputs of the I/O device. Now let's try the opposite way. As you can see, the values that are set in the output bytes of the I/O device are taken on the side of the I/O controller by the corresponding inputs. Let's get back to the configuration of the transfer areas. Click on the PN interface of the I/O device. Expand iDevice communication from operating mode in the General tab of Properties. Here you can see configured transfer areas. By selecting any of it, you will be able to edit its parameters. You can rename your transfer area. Change the direction of data exchange. Current transfer area direction is from I/O controller to I/O device. To change the direction, you need to change the type of the address. If you change the type of the address on the I/O controller side, TIA portal automatically makes corresponding changes on the side of the I/O device. It works same way if you change the type of the address on the I/O device side. You can edit starting address of both sides. You can select the process image in which your transfer area will be kept. Also, you can edit the length of the transfer area. You may want to add the comment. By ticking checkbox Enable PROFIEnergy communication, you can enable energy saving function of the PROFINET. You can edit other transfer areas same way. Just select any from the list and the edit window will show up. That were the basics on how PROFINET IO communication is done within the project. If this video was useful, please do not forget to like it and subscribe to the channel. Thank you for watching and happy coding.